Hello everyone, I am Bazooka Smooth, and welcome to another astronomy project. In this video, I will be analyzing Hatsune Miku's newest song, Confessions of a Telescope. I figured, since the title has telescope in it, and our project is about telescopes, it must surely be relevant and full of astronomical references. Okay, let's get into it!
Dear Dr. Jack, I've come to adjust my focus. Let your mirrors wash me clean, for
And by I'm, she means her.
I'm a telescope.
Okay, so as far as I can tell, this is basically setting up the premise of the song, right? Miku clearly states that she is, in fact, a telescope. Focus here is referring to where light going into the telescope converges. Adjusting focus is something that is often done to increase the sharpness of the image you're seeing. Basically, our main character here wants to see clearer.
I swore I'd never you again, but my medicine wheels spin.
So, actually, despite the name, medicine wheels can't spin. Pictured here. They are an archaeoastronomical structure of usually 28 spines in the ground to denote the lunar cycle, along with the stone scattered around that point to point out bright stars or constellations. Constellations. One of the most important things in the field of astronomy are constellations. They were some of the first astronomical observations even before telescopes and helped people navigate not just Earth, but time and season. Today, they help guide telescopes to the right part of the sky. So the theme of this section of the song has been about what primitive astronomy was like, and it ends with Miku being ashamed of the limitations of her unaided vision.
I promise I'd survey no more. Galileo can't ignore my inner workings are not diverging. Destroy the telescope.
Okay, so this is where the song turns into the creation of the first telescope in 1608 when Hans Lippershey designed it for land survey use. However, Galileo Galilei saw its potential for astronomical observation and upgraded the design in 1609. It worked by taking in light through a converging lens to focus the light and then a divergent lens to redirect the image into an eyepiece. It got up to 30 times zoom compared to the naked eye, before the image would be distorted. It wasn't until 1611 when Giovanni Domiciani coined the term telescope, which means to look far.
Kepler redesigned convergent lenses. Just watch, looking through the lens and mirrors.
Just as the lyrics state, another advancement quickly occurred in 1610 when Johannes Kepler, who you might already be familiar with if you're a real fan, changed the eyepiece into a convergent lens in order to fix the distortion issue present in Galilean models beyond the 30 times zoom.
Starstruck, shine the non-believer. Our observation would never be complete. Look far, tension with reflection.
Reflection is also probably referring to when the reflection rather than refraction telescope was invented. The tension being when James Gregory designed the first reflecting telescope, but it was never built and Newton beat him to it 5 years later. Reflection telescope diagram pictured here.
Snapshot, analysis, and measured data.
This line seems rather anachronistic here, but it's true now and way back when that, contrary to the popular depiction of astronomers in the media, astronomers don't just sit and look through telescopes all day. Instead, most of what they do is analyze images or drawings from the telescope.
Come on, can't you see the moon rising up to the sky?
The moon is especially important as a subject and device of astronomical study. Though Thomas Harriot made observations of the moon first, it took him until 1612 to publish his drawings. Galileo, on the other hand, had published his drawings in Starry Messenger in 1610, but he didn't just stop at our moon. And this is how he discovered Io, Europa, Ganymede, and Callisto, the largest of Jupiter's moons, which are now referred to as the Galilean moons.
Star parallax masterpiece observatory when?
2 for 1 here. The first reference is to the parallax effect, which was first measured in 1838 by Frederick Bessel when he noticed that the stars were moving despite the common belief being that the stars were locked in place. The second reference is to the founding of Yerkes Observatory by Gregory Hale in 1897, which houses the world's largest refracting telescope at 40 inches. And I believe this is foreshadowing.
Mr. Jack say a conquer to the heaven to sin. It's driving us crazy. The airship for safety, yet something shifts outside our atmosphere.
This first is referring to the launch of the first satellite telescope in 1962, named Area 1. It was also the first international space project since America funded the rocket while Britain made the satellite telescope.
That's where I won't detect again.
With developments in modern telescopy, we've been able to detect fainter and further objects than ever before due to the development of more refined lenses and sensitive image receptors.
But my aperture is thin.
And aperture, of course, is the diameter of the lens or mirror the telescope uses to collect light, or the light collecting power.
Astronomy cloud breaks down my neck. I wonder if I should my eyepiece. Resolution breaks my eyes.
Okay, pretty clever. Yeah, so resolution is how sharp an image is. Usually, a bigger telescope, larger aperture, and low air turbulence correspond to a higher image resolution, which is measured in arc seconds.
Adaptive optics are divine.
Adaptive optics is basically a way for astronomers to quickly fine-tune a telescope's resolution where the conditions might be unstable. A small, flexible mirror is placed in the beam of a telescope, then a sensor measures how much the atmosphere has distorted the image. As often as 500 times per second, it sends instructions to the flexible mirror on how to change shape.
CCDs rewriting history.
This is a good one! So a CCD is a charge-coupled device. They were invented in 1969, but before that, the most common form of astronomical detection was by a type of photography involving a piece of glass coated in light-sensitive chemical coating. After exposure, developing the glass plate would cause an image to form. This was inefficient, however, as only 1% of the light that hits the plate was detected. CCDs, however, in CCDs, photons of radiation hit the detector, and the places hit would generate a stream of electrons, which is counted and stored as a pixel. Generally, 60 to 70% of photons are recorded, and the highest quality CCDs can sense higher than 90%, allowing detection of fainter objects and more accurate measurements. One last thing about CCDs, output is recorded digitally, so information can be transferred directly to a computer for analysis. So yeah, they totally rewrote history.
I'm a happy telescope.
Something I think was missed is another type of visible light detection, infrared detecting, which is able to detect wavelengths outside the sensitivity limits of CCDs. The issue is with isolating the infrared light from space, which is really faint, to the enormous heat that the Earth gives off. So the detector's environment must be very, very cold. Usually it's immersed in liquid helium to be around absolute zero. And now that I'm thinking about it, there's also spectroscopy. This is a diagram of how spectroscopy works. Spectroscopy splits the light into different colors, which can then be read as a separate image before being combined into one full color image.
Someone please tell me what this is. I thought this was long-range radio communication. Where is the static coming from? And what would Dr. Jack think? And we know we're supposed to take this seriously. Somehow we just can't control ourselves. This is radio energy from space.
So this whole thing was basically how radio waves from space were first discovered in 1930 by Carl G. Jansky.
Linked scope to scope.
This line is referencing interferometer arrays, which are essentially a bunch of telescopes linked together to create more refined images.
The signals go! The signals go!
And this is explaining how multiple radio signals amplify the image and increase resolution.
Could Hale be a rhino? Could he lead us through the sky? We'd all be disciples of his progress-driven life.
Another reference to George Hale. Hale is awesome because his research and financial contributions did so much for the telescope community and for advancing astronomy. Truly should be as iconic as Galileo, perchance.
Can somebody show me? The air isn't steady. Still something shifts above this altitude.
This might be a stretch, but I'm pretty sure Miku is trying to allude to different viewing conditions, and is likely having a bad seeing observation session. The best conditions would be at nighttime when there are no clouds, wind, or humidity. Additionally, it is important to be as dark as possible and thus far from any cities.
The power resting in our hands, where Dr. Jack has other plans. With technology that could live like life at the modern telescope.
Here, Miku is just talking about how modern telescopes are capable of capturing images into photographs for us to see. Sometimes, these are visible light photos like commercial telescopes, but other times the photos can be in infrared like those of the JWST.
I can't resist it anymore, 'cause I sense the stars and more. All the changes from a simple scope could never the curiosity. Astronomy till I die. What's the point if I don't find? With the lenses that empower me, I can live a starry life.
And that concludes my analysis of Confessions of a Rotten Telescope. Please let me know if there's anything I missed, and if you like this video, please give me a thumbs up, and subscribe and share with your friends. Thank you so much for watching.